in Space. Thank you for joining us on this episode of the Today in Space podcast. My name is Alex Giorfanos. I'm your host and science communicator for this episode. We had the opportunity to interview Brian Stofiel of Stofiel Aerospace, who, with his daughter, are launching 3D printed rockets and making space more accessible to everyone. But first, we have to talk about your morning commute. If you live up here near Boston or anywhere near a city, or even if you just have to drive a long way to get to work or where you're going, then I have a question for you. And be honest. Aren't you bored of listening to music? Same old song keeps coming back on? Or maybe you just feel like all the time in traffic is a giant waste of time and you could be doing so many other things with your life. I've been there. First, I tried podcasting to switch things up, so if you're listening to this, then you're already halfway there. But one of the best things I did for myself was to try audiobooks. I was able to make use of my transit time effectively. Learn things I probably wouldn't have learned, and honestly, read things I probably was never going to read. So why not start with your free first audiobook and free month trial on us? Head over to audibletrial.com/todayinspace to get your first free audiobook and free trial on us. This week, I have to recommend Failure is Not an Option by Gene Kranz. This was one of the first books I read when I went to college to study aerospace engineering. Gene Kranz was the NASA flight director for Apollo 13 and the person that Ed Harris plays in the movie Apollo 13. But more importantly, Gene was an integral part in the American human spaceflight program, especially the Apollo program. You get to see the perspective of the origin days of human space travel and how they built the space program as we know it in America. From our humble and failure-ridden beginnings to our greatest triumphs and challenges, this book covers a great deal. If you want to get inspired about space travel and learn the history of American human spaceflight, then this audiobook's for you. Get it now by starting your free trial of Audible by going to audibletrial.com/todayinspace. And if you'd like to pick up any sweet space gear, we have plenty of merch from Today in Space that helps support the podcast too. You can find our t-shirts at $18 each on our Threadless page at todayinspace.threadless.com. We also have our rocket ship phone holder that we can 3D print for you on demand here at AG3D for $15. I use this thing every day when I'm working at my desk. The phone sits at the ready, at the perfect height to be seen while you're working. It's awesome. You can get one today by going to our Etsy shop at ag3dprinting.etsy.com. Now, back to this week's interview with Brian Stofiel and Stofiel Aerospace. So, Brian did not start in the aerospace industry, but decided to start a space company with his daughter, and they've been using 3D printing to create rockets that can deliver payloads on a regular basis. Brian stated that with their launch system, if you came to them wanting to launch on Monday, then you could have your payload in orbit by Friday. They're using some really amazing innovation to give more people, all people, access to space. I found out about them on Twitter a while back, and we've been following each other for a little bit here, but what really brought my attention to Brian was seeing him defend himself against some pretty biased and opinionated journalism. Again, in quotation marks, journalism. Brian did an amazing job of fighting back and defending himself and his company's development on the savage Twitter sphere, and I have a lot of respect for people who in this day and age defend themselves and fight for what they believe in. I learned so much from my phone call with Brian, things I had never thought of, concepts I never had introduced, and if I could describe it in one word, it would be wow. This was one of my favorites in 4 years of podcasting. It's capturing moments and conversations like this one with Brian, telling the stories of the people or robotic emissaries that explore the final frontier that made me want to start a space science podcast in the first place. Now that I've got a taste for it, I'm very excited to see who else we can talk to and what other stories we can help share with Today in Space. Another good conversation to go see is our interview with Jerry Goodson, episode 126, who was a veteran of the space shuttle program and worked all the way through from being a technician on the aft side of the spacecraft to being a space launch test conductor. So people that are in the industry doing their own things, I love this stuff, so go check that out. In the meantime, please enjoy this one. Buckle up and get ready to, as Stofiel Aerospace says, fly high and burn hard. All right, today in space, we're talking with Brian. Is it Stofiel? Did I pronounce that right?
Stofiel.
Stofiel.
That's correct.
Welcome, Brian. It's so good to talk to you.
It's a pleasure to be here.
A could you please give us the rundown? Where does Stofiel Aerospace come from? What are you guys doing? Because it's exciting, and I want to share it with people.
Well, me and my 12-year-old daughter, about 5 years ago, decided that the space industry was about to pop off. So we began developing a small satellite launcher. And the way we're doing this is we 3D print PLA plastic, and then we apply a heat coating ceramic that we developed to the plastic, and fire live rockets through it. We call it positive structural molding. So what we are is we are a raccoon system. So that means that the rocket rides a helium balloon or a hydrogen balloon up to about 100,000 feet, and then we fire the rocket from there. And the Hermes rocket is fully solid rocket only. We have no liquid propellants. We're able to throttle, thrust, and vector a solid rocket efficiently for orbital insertions. So it's a very unique launch. It's not a new launch type of profile, but using a solid rocket is pretty unique in the industry. What it does allow us to do is scale the rocket to the payload and produce these things in a mass quantity that we can provide on-demand service to low Earth orbit. Scaling, we can scale between 15 kilograms and 250 kilograms, about 500 pounds, 800 pounds, somewhere in there. And then what it does is it gives you that on-demand access to low Earth orbit that is the next milestone in space. Reusability is great, but being able to fire, if you want to fire a rocket tomorrow, we could fire a rocket tomorrow. Type of capability is what we see as the small satellite advantage.
It's such a smart little it's such a smart niche that you're getting into here, and I think there's so many things that could be innovated and changed in the space industry right now, and you're capitalizing on something that has so much influence on the industry as a whole, between educational opportunities. I had the opportunity at my college, Worcester Polytechnic Institute. We did my capstone was a CubeSat. It was a 3U stacked CubeSat that was going to take solar weather readings, about a year in orbit, and then would have decayed. And so as an educational experience, we got to go through the entire mission profile. We had our own teams. We worked with our teams and had the opportunity to, within a year, work on a mission that had applicable use and could have been launched if the availability was there. And that's why I joined that project, and most of us did, because we were told we were going to launch.
Yeah, so we're set up to
possible.
partner with St. Louis University. Here in St. Louis was one of the very reasons we located our headquarters here. Mm-hmm. They have already put 4 CubeSats in orbit.
Wow.
And they blew one up. But, yeah, they put 4 CubeSats. So it was a pretty big move to move here to St. Louis to become part of St. Louis University as my PhD.
Wow.
So the actual rocket is my PhD, right?
Good for you, man. This is awesome that you're applying that.
Yeah. I went back to school at 35 years old. I had a previous life as an MRI radiology engineer. I fixed MRIs, CT, ultrasound, all that high-tech equipment. Mm-hmm. 35, got divorced, said, Bella, what do we want to do? She goes, well, do you like space? I like space. Let's go to space. So we started this. There's a myth out there of entrepreneurs being young college kids. Mm-hmm. Most entrepreneurs I've met in the last 3 to 5 years are above 30 years old. Mm. They're already done. They've had some life experience, and they're ready to start a business. So it's kind of interesting for the media-wise because we have a 12-year-old daughter, my daughter, who's been on this journey with us also. And we've gotten perspectives from her that we couldn't get from anyone else. She looked at me one day and goes, well, I guess we got to build a rocket.
Yeah.
Because we ran into the launch problem. We had a satellite, like you said, we wanted to put into space. And the problem was it was going to take 4 to 7 years and about $4 million to put a 50-pound package into space.
Which is just impossible to get into at a small level.
Yeah. Yeah, so at 5 years old, I looked at her and I said, what do we do? And her reaction was, it looks like we need a rocket. And we need to be able to fire things into space on our own.
I love that.
So that's what started this journey. This last year, she looked at me and goes, if I knew what I was taking on when I said that, I probably wouldn't have said it.
She's a smart girl.
Yeah, it's been interesting. But we've kept her involved. She goes to business meetings with us. We really tapped into her ability to grow up with technology that we don't understand.
That's beautiful. Just to go off on that, if you don't mind.
Yeah, go ahead.
So I'm 28 years old. I worked in the manufacturing industry at a plastic injection molding shop, and I was in my early 20s, and a lot of the young kids were getting into it because the manufacturing industry, basically everyone was in their 60s. The industry was about to lose their vets and their knowledge, so this company I worked for was smart enough, Westminster Tool, to say, hey, we need to tap into our younger generation, and there's a fresh eyes aspect to someone who's brand new to it. And I think the aerospace industry is pretty obviously complex, and the details are everything, but sometimes it gets caught up in what we've been doing and not so much what can we do.
And that we call that industry bias.
I like that.
So what we've seen is, because I come out of a very high-tech industry that moved very quickly, the medical imaging industry, nuclear medicine, ultrasound, anything in the radiology department, right? Everybody thinks they're the only ones to solve the problem, that they're the only ones that have this problem. So inside the industry, they solved it one way. If you looked at another industry, they have similar problems, but they solved it different ways. Right. So as soon as you're able to look across an industry and say, okay, look, the medical industry does it this way, but the aviation industry's got the same problem. Cryogens is where my expertise lies. So I know a lot about and I look at the difference in the engineering methodology. Okay. You can see that the way that the aerospace industry is doing it is not just the only way, and it's probably not the best way. Because I come out of the medical industry with a superconducting magnet. Yeah. Right. I got a lot of energy next to my cryogens. If we get any thermal coupling, we boil off $100,000 worth of liquid helium. Yeah. So being able to look across industries, and that goes back to that young person who never has known a time when they couldn't pick up the internet and answer any question they have. What I tell to the kids is, when I talk to the kids, is I say, all of human knowledge is on your phone. Stop looking at cat videos. You got a question, go answer it. It's probably there. Yeah. So that's the kind of attitude with the 3D printing and the on-demand, what we call on-demand manufacturing. That allows these kids to take an image, their imagination, and an image in their head, and within a couple hours produce a physical object. So we've given classes to the kids to come to understand this, and within about 5-10 minutes of me teaching them Tinkercad, I have to back away, and they're off to the races. Okay, once they understand how it works and what they can do with it, I have to kick them out of the house.
Right. You got to get some sun.
Your mom's here. She's been here for an hour. It's time to go.
I have a similar problem. I mean, Brian, that's amazing. I mean, that's literally, I've created a company from that idea you just said, and I bringing ideas into reality. Once you understand, so I've done CAD for 8 years. I worked in aerospace R&D, so I've done some designing for about 8 years now. My boss was smart enough to say, hey, build it yourself, design it, learn how to manufacture it, learn everything about this machine. Just learn how to do it, and that way you'll go faster. And then once 3D printing came into the picture, my God, I mean, it really is. It hasn't even gotten off the ground. Like right now, it's at the level. I like to compare it to the telephone. We're at the point where the operators were plugging in lines and transferring. Like, we're not even at the iPhone. We're not even close to it.
The on-demand manufacturing, there's already a shop in New York City where you walk in, computer scans you, you choose your clothes on the screen, and then it prints the fabric, right?
Yeah.
It's an automatic loom.
That's wild.
So you go in, and it's custom tailored to your body.
Whoa.
Right now you're custom tailored. So if we expand this out a while, 10, 20 years, the Walmarts, you no longer have to do mass production because you can do on-demand manufacturing, right?
Mm-hmm.
As soon as you need the object, you manufacture it. Okay. This is what the changeover we're seeing in retails that we don't quite understand just yet. Okay. It's hidden inside of Amazon's platform or the online platforms, right? And
I've even seen, slight adjustments like Walmart is doing something like delivering the food right to you because the demand is changing. And then it's the same thing you guys are doing with the space travel demand.
Yeah, pure customization is the way to go from a manufacturing standpoint. And we've taken that to the one step further with the aerospace and said, look, you bring us your payload on a Monday, we want to have it in orbit by Friday.
I love that. And
that's how quickly we want to produce a rocket.
What's your motto again? I don't want to butcher it.
You bring us a payload on a Monday, it's in orbit by Friday.
I got it. And is it fly high?
Fly high, burn hard is the tagline, yeah.
Right, that's amazing.
Because if you think about it, the balloon Boreas it flies high, and then we actually burn the rocket pretty hard.
Yeah.
Solid rockets are pretty. They're not something you want to put a person on.
Right.
Put it that way. Okay.
So and let's go. Oh, go ahead, Brian. Sorry.
Go ahead.
No. So let's go into the technology because. From a 3D printing standpoint, I think a lot of people who are into the 3D printing industry are saying, how can you be launching a rocket that's being lit and going up to those temperatures with PLA? I mean, I deal with customers where the understanding is right now that PLA is just rapid prototyping. It can't be used. And I've seen a lot of success, so I'm excited to hear where and why you guys chose PLA.
All our tests are done with PLA plastic. All of them. We've used some flexible PLA. It's using the properties of PLA. It actually helps our ceramic, and we actually produce a ceramic structure.
Okay.
So the PLA is a positive mold for us.
Oh, wonderful! That's amazing.
And then we apply the ceramic to it, and all of this is patent pending stuff. So we will be able to release this as a product in a process.
That's amazing.
The heat coating itself is endothermic, so it protects the print until it goes into its fluid state. And then with the pressures and the shock waves and everything going on inside, it pretty much is we're sitting inside a fluid state. So we've got a ceramic, I like to offhandedly call it glass nozzle. And to prove to the point is I'll wait for a second after it being 3,000 degrees because that's what these rocket engines are burning at about 3,000 degrees. And after about 10-second burn, I'll wait maybe a half a second. It takes me to walk from where I was standing to the nozzle, and I'll pick it up, and it's 70 degrees on the outside. We register less than 100 degrees. So our hobby coating, I'm going to give you the scoop. This is free for everyone to use. Graphite. Spray your prints with graphite. Okay? Before you do any finishing, we can put one of these prints, a PLA print, sprayed with graphite. I can put it in the oven at 240 degrees Celsius for up to 20 minutes. Conductive heating is your enemy. It's not radiant heating, it's conductive.
Okay.
So if you're touching a hot surface, that's where the failure point is. So the graphite takes up some of the space inside the PLA print and allows it to actually prevent the conductive heating. So you want to let your prints survive out in the middle of the sun in the summer. Keep them off that hot dashboard, because the actual dashboard surface is conducting the heat to the print.
Okay.
Not the air around it.
Wow, that's a great tip. No, Brian, that's craziness.
I've got a Star Wars helmet. We actually did some infrared masking on it. So it's got infrared camouflage, just to see some effects of some of our ceramics. With the ceramic process, we can use it a couple different ways, and we've got all that spaced out. So, but yeah, the quick prototyping is what is allowing us to advance very quickly. We fired 37 of these rockets. Currently, we're surviving a 10-second burn at about 200 pounds of thrust in an 8-pound rocket.
Wow.
So very power to weight ratio.
That's incredible.
Yeah, the power to weight ratio is immense. Okay. Being able to manufacture a nozzle, do the math, and 48 hours later have a new nozzle with new geometry. That ability has allowed us to do things that we would normally not do. Because each one of these nozzles is costing about $1,000.
Yeah.
Versus 10,000.
Right. Yeah. So just that cost alone, and then just to put into perspective, just for folks that are listening and might not know, and correct me if I'm wrong on this, but the amount of time it took for these launches to happen and each launch to then develop was a long time. And I think the trap that the industry fell into was the term flight-proven hardware. And
well, it's worse than that. It's the fact that they want to study everything at the same time. Horizontal integration. So what we've set up is a vertical integration. We finish out one piece of technology before we integrate the next. We don't try to build everything at the same time. Okay. The industry itself likes to build everything at the same time. So you're trying to integrate the computer system with the flight hardware, with the structure, all at the same time as you build it. And I think that's a trap inside the industry. It's one of the industry biases. The flight-proven hardware, it just means you have to run a lot of tests.
Right.
Okay. And you got to have backup safeties and survivability. But what happens is, going to do that, they want to produce a perfect prototype every time they test.
Yeah.
Whereas we produce, I'd say probably out of the 37 we fired, 4 of them were totally imperfect, would never have been fired ever, would have been thrown in the garbage.
Yeah.
But we fired them anyways.
Yeah, right.
Because they taught us something.
Right.
Right? There was one that I built backwards on accident. I built a couple of the structures backwards, so they were 180 degrees out of phase.
Could you explain that? Anyways. Could you explain that a little more?
I can't.
No worries.
There were structures inside the nozzle that were wrong.
Okay.
And normally I would have tossed it. Okay.
Yeah.
It was because of my manufacturing, my understanding of manufacturing, of how to manufacture. I messed something up.
Oh, I got you.
So what we did is we just fired it anyways.
Yeah, see what you learned.
And we proved a couple different things that we didn't know.
Really?
So some of the bigger companies, they don't allow you to just do things to burn things. I don't want to, that's a bad, how do I describe that better? Do things just to fail.
Yeah.
Right? They want you to figure it all out and then build it and then try it. Right? We really do stuff to fail. My heat coating is a great example. I've done things to make it try and fail. So I put zones inside the nozzle that was going to cause massive turbulence, and it did. But the nozzle didn't fail.
You wouldn't have known that otherwise.
I wouldn't have done it otherwise.
Yeah.
But the low cost and then quick repeatability is where we're in the real zone here.
Yeah, the iterative design process.
Yeah.
Yeah.
Yeah. By the time the Mark IV, I'm already starting producing the Mark IV nozzles. We'll probably produce somewhere around 50 of them this summer. We're hoping for.
Wow, that's awesome.
Yeah, everything's coming together. We're getting everything set up. We got the team set up now. We're applying for flight trial tests with the FAA. We're going to be part of DARPA's launch contest in December 2019, and that is our orbital date. So we'll do our orbital trial at DARPA December 2019.
That's awesome.
Up to that point, we'll be flying suborbitally, going up to 750,000 feet and coming back down to the ground type of stuff.
Okay, is that testing the ride up?
Yeah, well, it's testing the hardware as we build it.
Okay.
So we built the engine first.
Mm-hmm.
Now the engine works. So now we got to build flight controls. We got to build our situational awareness. We got to build our orbital computer.
Gotcha.
And then we can actually fire all that. So leading all up to that is that vertical integration where we finish out a flight computer and then we move on to the orbital computer. And when we finish the orbital computer, we move on to the drone, to Hyperion. So the whole system's named after Greek gods.
Which I appreciate as a Greek man. I really appreciate.
Yeah. So as Hermes, Boreas is the balloon, Hermes is the rocket, Zeus is the orbital computer, Artemis is the drop drone, and Hyperion is our small satellite deployment vehicle.
I love that, and I like that the naming is important to what it means to the whole system. I think that's
correct.
That's very smart, and I like that.
Yeah, because once you understand the naming, you kind of understand what's going on.
Right. Yeah, you know what that system's purpose is. You're like, oh, okay.
Okay, yeah. So yeah, it's a great little scheme. Up to this point, we've been naming them after my daughter. And then the flight trials we're naming after our ferrets. So it's Nicodemus, nice. Malachi, and Memnon.
You guys have great naming schemes. I love it.
Yeah.
So, Brian, where can people follow? Are you guys going to be posting about launches this weekend? Where can people follow you and find out more?
Stofiel.space is our main website. It's under construction at the moment. Like I said, that we're no longer shortly going to be family-only financed. So they can check out there. All of our social media is active. So Instagram, Twitter, Facebook, LinkedIn is probably the one that I put the most detailed information about.
Okay, good to know.
So my LinkedIn profile. But yeah, we are a small family-run generational company that my daughter wants to be a biological engineer. She wants to engineer biology. She thinks the ultimate spaceship is a living spaceship. And we're actually targeting the Saturn system and Titan, the Saturn moon Titan.
You know,
our eventual goal.
I saw that in your video. Your guy's ultimate destination is Saturn.
Yeah. Saturn system's pretty benign radiologically, so there's no. Jupiter's got a huge radiation belt.
Mm-hmm.
Saturn's pretty quiet, and the diversity of moons in the Saturn system offers us a very wide look at life, because that's what we're looking at. That's what Bella's interested in. Titan's got 164 different hydrocarbons. And the discussion between me and her goes that when the rings were formed, Titan was a primordial Earth that got freeze-dried.
Whoa.
So it's freeze-dried in a primordial state. And then Enceladus is just like Europa in the Jupiter system. It's a water world covered by a sheet of ice. So those two alone for life could mean big things. Especially if Titan is what we think it is.
Mm-hmm. And I'm sure the Cassini data has been incredible.
Huge.
Yeah.
Yeah, it's been a big influence on our decision. Now, we do have an intermediate goal, which is a asteroid mining survey of the asteroid belt, and we hit about 6,000 asteroids with 3 different passes from 3 different spacecraft. And we can do the whole asteroid belt with about 20 spacecraft in about 2 years.
So I just want to make sure I have the vision correct. So these are all CubeSats that you can launch with your system?
Yep.
Wow.
So we have a mothership that runs a fairly close orbit to relay signals, and then we run CubeSats on a high-speed racetrack through the asteroid belt, and we pass every asteroid with at least 3 different spacecraft with 3 different sensors from 3 different angles. And we call that generational data. That's data that Bella's grandchildren will still be selling to asteroid miners down the road. The prospecting for asteroid mining is probably humanity's biggest advancement.
Yeah.
I don't want to be one of the guys going out there and pulling the stuff back and doing the mining.
Mm-hmm.
But I'll sell you your pick and your gold pan.
That's funny. That's when people ask me, would I go up on a rocket? My first question is, I don't know, but I'll help you get there. Yeah, I'm with you there.
Well, I'm going. I'm going. I will see it by the end. The only way I'm going to see it is if I build it myself.
Yes,
I've got
Brian, you're hilarious. I love
that isn't dangerous, but it excludes me from any astronaut program.
Could you say that one more time?
Literally, I have a genetic heart murmur.
Really?
And it excludes me from any astronaut program.
Okay.
So the only way I'm going to space is if I build it myself. Because that's the only way anybody's going to let me do it.
Brian, I love your determination, your ingenuity, and your creativity that you're doing this with your daughter. I can hear it in your voice when you talk about this. You're passionate about it. So I'm excited to share your story, man. I think Stofiel Aerospace has a lot of great things to come in the future here.
We've got a lot of great mentors. Like you had mentioned, we work with the old Mac's old team here in St. Louis. Mac's old team are the Mercury and Gemini engineers that worked at McDonald Aircraft Corporation here in St. Louis. Mm-hmm. So these guys did what we do, is experimentation, right? They didn't know how to do space.
Right.
So they've been a big influence on us to say, look, your experimentation is good. Keep going. That was a big influence on us, to have those guys tell us that our experimentation looks good.
Yeah.
That they're amazed at what we've accomplished through this experimentation. So it really is nice to have them on board. We do have a crowdfunding on Indiegogo called Launch Legacy. And it's basically to pay for these guys. We're doing a documentary on them.
Good.
And at the same time, we're taking them back to space with us. So these legacy guys are in the Mac's old team are going to be at our launches. We've named one of the rockets the Mac old rocket. And that way we can show these guys what they meant to the program. Because these are the engineers that did this.
Yes.
If you talk to the astronauts, they say, look, I was told to get into something and push a button. Mm-hmm. I was along for the ride.
Yeah.
And if you ask my daughter, she doesn't see astronaut as a job. What she said to a reporter one day was, space is just where I do my job. It's another place like New York City or LA.
Right.
It's no different.
No, she's 100% right in that. And
yeah.
And there are just as many infinite ways for people to be involved in space. It's biology, it's chemistry, it's
sports.
It's sports. Thank you.
Yeah.
Yes.
I mean, the astronauts have to be able to exercise in space, and they have a sport. That's exercise.
Yeah.
That's why we play sports, really. To have something to play in space in zero G to keep all your muscles toned, all your bones from impact resistance. Mm-hmm. Yeah, that's going to be important, and people don't think about that.
Nope.
What I tell the kids, and kids are really our marketing. We market to the 7 to 14-year-olds quite a bit. And we tell them a lot is, look, I don't care what you want to do. You want to be a sports, you want to be an actor, you want to be a scientist, you want to be a doctor, you want to be a lawyer, you want to do plumbing, okay? You want to be an electrician. I don't care what you want to do. We want to take you to space.
Yeah.
We want you to do your job in space. The resources that are available to us in space are infinite. Literally infinite.
Yeah, we'd literally be unable to get all, like, yeah.
So the analogy I make with kids is, if you stayed at home and never brought anything into the house, you'd eventually pollute your house. You'd use up all the resources and you starve to death. And that's it. Earth is a finite space. Okay? If we want to expand, we have to use the infinite. We have to go outside to your neighborhood market and bring resources back to the house. It's as simple as that.
Yep.
And we just get it. And we understand there's ethical problems, and I do bring them up to the kids with, is the planet alive? Which planets are alive? Does Mars even have anything on it? And what is our responsibility to life?
Yes, and those kids, go ahead, sorry.
Those kids, they get that. They understand that a dead asteroid is a dead asteroid, right? There's nothing out there. It's more of a danger to leave it wandering around. Go ahead.
Oh no, you're my head's going in a million different places here. This has been an amazing conversation, Brian. Just what you're saying about making it simple. I really think, we talked about the trap the industry's in right now. I think that's the trap for space in general. I think people are thinking, making it too complicated. You know, something can be simple.
That's the danger.
Well, there is danger.
That's
you're right.
danger.
There is, and
the industry. Well, everybody thinks that space is hard. Space isn't hard. It's that complexity that space brings that actually makes it difficult. So we understand how to do space. We're pretty good about physics now. We understand pretty much how to do it. The problem is there's a built-in complexity of what we have to deal with. And that's where everybody gets into the trap. More complex is not the best.
Right.
Okay? But that's where industry leads to. Is more complexity. Especially government-run industry.
Right. Right.
Okay? Because the more complex it is, the more money you can ask for, the longer the project takes, the more you got a job. And that's where commercial industry is seeing it. You know, the straight complexity of a Falcon, of a SpaceX rocket, versus what NASA's building. Okay? Yes, NASA's is much bigger.
Right.
But the complexity is also hugely different. So it's going to take industry to take that complexity and narrow it down to what is required and not what is the standard industry standard.
Right.
There's a discussion going on about on-the-pad fueling and on-the-go fueling. Okay. Basically, you got people in the seat and you're fueling the rocket up, right? Well, that the industry standard is you fuel the rocket up and then you put people in the seat.
Right.
But loading wise, that's a pain in the butt.
Yeah.
So they'd like to put people in the seat, load the rocket, and go. And this is an industry standard. The first time we approached the FAA and told them we wanted to fire 1,000 missions a year, they told us that would never happen. I was out of my mind, that you're crazy, you'll never get that, we'll never be able to do it. The rules alone will prevent you.
And if you look at the world from the industry lens of how complex it is, which it is, then and how they're doing it, they're right. But you're not doing it that way.
That was just the FAA.
Right.
That was just the FAA's perspective, right?
Right.
We go back now fast forward 2 more years, we go back, tell them we want to do 1,000 missions a year, and they say, okay, how are we going to do that? A lot of the giggling and laughing and anger was gone. It was, okay, we think you can do this.
Right.
So it has changed a lot, and Bella's probably part of that. We lobbied, the RNC in Cleveland was less than a mile from our office.
Mm-hmm.
So we lobbied 18 senators, 13 congressmen, and she talked to Trump on the phone and Pence in person. And she was lobbying for commercial spaceflight. That was her line, was commercial spaceflight all the way.
Good for her.
So we really think she had an influence, because the administration's been great compared to previous administrations, coming into new startups, new space, and the acceleration.
Mm-hmm.
DARPA just put out that launch contest I mentioned earlier. They've staggered prizes, and these prizes are big enough for the big players even to take a look at.
Mm-hmm.
So it's going to be an interesting couple of years. What I say about the aerospace industry is microization that happened 20, 30 years ago in computers and cell phones and TVs and basic electronics have now filtered into the aerospace industry and are good enough to run it. So as you're thinking about things like AI, we're thinking about things like being able to change orbits with most efficient ways and using microcircuitry that has never been used before in space. Even the space shuttle used big floppy disks to program the computer. To give you an idea, the space industry is starting to embrace the microcircuitry as an effective way of dealing with the radiation environment. So that microization is now filtering into the aerospace. You'll hear some companies talking about going from Sydney, Australia to Chicago in 2 hours. We could put a rocket theoretically anywhere in the Earth in under 2 hours. So you need a package on the other side of the planet in 2 hours. It could be there. And that's what the change in aerospace is coming.
Wow.
The big one is going to be when they figure out the Shockwave problem with hypersonic aircraft, because they're easier to produce, they're cheaper to run than commercial aircraft now.
Okay.
So you can produce a hypersonic aircraft cheaper and easier, and then run it and maintain it cheaper than you can a regular aircraft. So it's going to be interesting. Long hops are going to be actually less expensive than short hops. So there's a prediction for the future.
You know, once you said that, yeah, thinking about it, that does make sense.
Yeah. So from here to Sydney may only cost you $200, but from Chicago to New York City is still going to cost you $800.
Let me see if I got the logic right. Logic being, if it's a shorter hop, it's got to slow itself down more, and it's got to maneuver itself more. Where it's in orbit longer, and you could just really toss it up there and then have it come back down.
Correct.
Okay.
Correct. So it's going to be more efficient to run a longer flight than it is a shorter flight, and that's what scares the military. Right? These hypersonic weapons, you hear it in the media already. Putin said he's got one. These are things that are traveling at Mach 7, Mach 8, Mach 9, 4,000, 5,000 miles an hour, to give everybody a reference point. The worry with the military, even with civilian spaceflight, is you can misuse it.
Yes.
Weaponization is easy to do. Right? So you bring in a piece of tungsten at 17,000 miles an hour and you drop it on a city. It's a nuclear weapon.
Right.
You destroy the city.
Yeah.
And this is where people really need to understand that space flight, when they talk about people having space flight open source or even other countries, that we understand this is a weapon.
Right.
We may not use it as a weapon, but it can be misused.
Yeah.
And that's why there's a lot of the secrecy in the space industry we don't agree with.
Right.
Is because of the military background. So we've tried to be open and as available as possible to everyone, especially the kids.
Right. And just to tie this all up, Brian, because I think this is a great place to tie it all up in a bow here. There's a big picture part of space, and there's the details part of space. Both of them are super important. And the industry has come from the military, so this is for people who might think, oh, why is it? This is where it came from. This is where it was developed. And for us to be able to go into space and do what we need to do and expand it so that it's accessible to everyone someday, we need to talk about it. We need to have these important discussions. And I'm glad that you brought those things up. Some people might be like, oh my goodness, like that's terrifying. I don't want to do it. But it's the reality of it.
Right.
And I think there's a balance we need to come to where we're thinking big picture and we're thinking at the details, because it is dangerous. You're right. And I didn't mean to play that down earlier. And I'm glad that you brought it up so that we had it, in the same conversation. I can get carried away sometimes being excited about it. But you're 100% right. Correct. You're 100% right.
And the big thing is intent. It is the intent. We have turned down people for weapons. Mm-hmm. Okay, because we don't build weapons.
Right.
I will weaponize things, but I don't build weapons. There's a big, significant difference there. Our spaceflight program's too important to take time out to build a weapon.
Right.
We feel a sense of urgency on what spaceflight is needed for humanity. There's a going theory that the best thing we could do for the Earth is get all of humanity off of it and turn it into a wildlife sanctuary. Okay, and just let it go back wild and become of truly spacefaring race. Take these dead planets and turn them into it. Now that's way long views, right?
Right.
But if you think about it in the long run, that would probably be the best thing to do. If you were really honestly wanting to save the Earth's environment.
Right, and I think that's an important... I've never heard that said before. I'm glad you did. Like, if there's a way to cap climate change and all the passion that's behind climate change and saving the planet, and putting an applicable place where we can innovate and do science, I think would bring that message along. And I think that's a good heading to have in our journey towards that idea of expanding into the universe.
It's infinite.
Mm-hmm.
You can't run out of space.
Yeah. You got it, man.
Well, it's been a pleasure.
Brian, same here, man. I hope to talk soon.
Will do.
Good luck with everything this summer with all your launches. We'll be following online.
Well, stay tuned, Space Cowboys and Cowgirls. It's going to get fun.
Thank you, Brian. Have a great day, man.
You too. Bye.
Bye. So, folks, Brian Stofiel, Stofiel Aerospace, an amazing story of innovation happening in the space industry, and beautiful story of just the people that first did space, that didn't know how to do space, and were the pure creators and innovators teaming together with this family company that is trying to expand into the universe and help humanity expand into the infinity of the universe. Amazing conversation, fun podcast, one of my most fun so far. Thank you guys for listening. Make sure to spread love and spread science. Have a great day, and we'll see you for the next episode.